Hi, today we're going to be looking at changing forms into standard form. And you might have a bias right now, and I wouldn't be surprised at all, against standard form because it seems very inconvenient, right? It doesn't automatically tell you a vertex, it doesn't automatically tell you an x-intercept, it tells you very little automatically. However, there are times when standard form is going to be useful, and we are going to be looking at those more in Unit 3. But for that reason, it is very, very important that we be able to convert between different forms, okay? So the first couple examples we're going to look at here are converting from vertex form to standard form. And the most important things to remember here are that you still need to follow order of operations. So you need to deal with any parentheses, any exponents, before you worry about the lesser emphasized things of multiplying and dividing, adding and subtracting. That is the order of operations. So I'm looking here in this first example at a problem where my parabola is expressed in vertex form. I can see that its vertex would be at 7, 3, and that's very nice information to have. However, there might be a situation where I would really like to have this in standard form, okay? Same parabola, but just a different format. So the way we're going to work on this is thinking about order of operations. X minus 7 squared means I have 2 x minus 7s. And then I'm going to work on multiplying that out using our algebra skills. So right in here, I see a little problem where I'm going to multiply out two binomials. The 2 I'm going to bring down. Here I have x times x, or x squared. I'd have minus 7x minus 7x. That's minus 14x overall. And negative 7 times negative 7 is positive 49. My next step is going to involve distributing that 2, the multiplication by 2, into the addition and subtraction problem I have in the parentheses. So I'd have 2x squared minus 28x. Ooh, getting big numbers here. 2 times 49 is 98. And then I have that 3 at the end. And these are like terms that I can combine. Okay, on the left-hand side of the equation, if I brought this down all the way, all these left-hand side expressions would be y. So this is my parabola in standard form. There are a few things that I know from both looking at the vertex form and looking at the standard form. The vertex is easier to find in the original because that was in vertex form. My vertex is at 7, 3. I know because the 2 is positive that I have a smiley face parabola, which means that that vertex is a minimum, okay? Will be a low point. The line of symmetry, as always, goes through the vertex. It's a vertical line, x equals 7, and the y-intercept is actually easier to see because of knowing standard form. This value here at the end is my y-intercept, and on the y-axis, the x-coordinate is 0. So 0, 101 is my y-intercept. All right, the next piece of our lesson requires you to do the right thing, okay? My direction here is that you need to pause the video, and then you're going to come back in a minute, and you will quickly see me write out the answer, okay? So I'm not going to really talk through the next example. I'm just going to be writing it out. I want you to pause the video first, though. Try it yourself, and then come back and see if my speedy writing matches yours. Okay, you should already have this already worked out, so I am going as fast as I can through writing this. Right, we're going to have used multiplication of two binomials, what some of you might call FOIL. We're going to distribute the 1/2. We're going to combine like terms. Okay, I hope that's the answer you got. If it's not, stop the video again and ask for some help, okay? Look back at your notes, figure it out. Okay, so the vertex is going to be easiest to see in vertex form. Go back to the original question, and we know that the vertex is at 4, negative 5. This is also an upward-facing parabola, so we have a minimum for our parabola. The line of symmetry is a vertical line through the vertex, and the y-intercept is easiest to see on what we just figured out. This value at the end is our y-intercept. Okay, so there was an example I led you through. There was an example I asked you to do by yourself. All right, if you feel confused, make a note to yourself that you need to ask for some help on this, because the next thing we're going to do is moving from factored form to standard form. Again, we need to follow order of operations. I'm going to do one problem, talking you through it, and then you're going to do a problem on your own, very much like what we just did. Okay, so in this problem, I see I have a bunch of multiplication. I'm going to choose to multiply these two things together first. So I have -2, and then the part from the green box is x squared. I've got -6x and also plus 1x, so that's -5x. And then -6 times +1 is -6. Okay, so all I did there was multiply together the two things in the green box, right? Multiplying binomials, you distribute all the terms or use FOIL, first, outer, inner, last. I did combine two terms that were alike. Now I'm going to distribute the -2. Remember that a negative times a negative is positive. So you'll see in these two spots, right, I have a positive and a positive here because a -2 times -5 is +10. -2 times -6 is +12. So boom, here is our standard form already on the scene. That's awesome, okay? So our vertex is actually kind of hard to see in this because we didn't start with vertex form. We might want to use -b over 2a. So my b value is 10. So opposite of b over 2a would be -10 over 2, and then a is -2. So I've got -10 over -4. When I do that math, I get 2.5. Now to get the y coordinate, I'm going to go back to this expression maybe. I say maybe because it's not the only opportunity, not the only thing I could do. I just plug in 2.5 for all these x's and find out what y goes with that. Okay, so that's going to be 24.5. I'm not going to necessarily dwell on that math, but hopefully you all understand what I'm saying. You just plug in 2.5 for all the x's, like that. And then that's your y. Okay? Now, in terms of understanding if that's a max or a min, we have to look back at the equation, either one of these places, and we see we have a negative number in the front, right? Negative a value. So that means we have a parabola that is a frowny face, which means that we have a maximum. Our line of symmetry, as always, goes through the x-coordinate of our vertex. And our y-intercept is easier to see because we have a standard form. So the constant in standard form is our y-intercept. Whew, that one had some tricky decimals in it, right? But that's okay. Numbers can be decimals, okay? The next problem doesn't have any yucky decimals in it, okay? But I would like you to try this by yourself. So like we talked about last time, okay, when we had a parallel problem, I want you to hit pause in the video, work at your own speed, and then come back and you're going to see me write down the answer for the problem really fast, okay? I want you to pause the video so you can work at your pace, right? And then come back and see how you did. Okay, if you're back here, you should have worked out this problem already. I would imagine that you multiplied these two things together because that's what I did in the other example. So x times x is x squared. This would be -5x. This would be -3x. -3 times -5 is 15. So if you combine like terms, you'd have this. Some of you might have jumped to that right away, and if so, good for you. Then you distribute the 2. And this line in yellow should be your standard form. Okay, so to know the vertex, I'm going to do the opposite of b over 2a. So opposite of b over 2a is going to give me opposite of negative 16. That's positive 16 over 2 times 2. 2 times 2 is 4. 16 over 4 is 4. So I know my vertex is 4 comma something. To figure out the y that goes with that, I need to put 4 in for all the x's. I'm going to borrow some space up here because I'm kind of squished in my spacing. This is what it would look like. I could type this in exactly on my calculator. I just put in 4 for both x's, and I'm going to find the y that goes with that. And when I do that, I get negative 2. So our vertex is at 4, negative 2. The line of symmetry is a value of the vertex. It's the x value of the vertex. And my y-intercept is always the constant at the end of standard form. So my y-intercept is 0, 30. Okay, there are 2 more practice problems down here, okay? So let me tell you what, I'm going to do the same thing. I want you to pause, and then I want you to come back. And I'm actually not even going to talk anymore. I'm just going to write down answers for the rest. But I don't want you just like writing down what I write down. That's not going to teach you math, okay? You need to try these 2 problems and then see if you get the same answer after you've tried, okay? So please hit pause. Okay, and if you're listening now, you should have already tried these problems. You should already have these answers. I'm not going to show all the work for it. I'm just going to allow you to check your work by looking and seeing if you get the same things. Okay, and then on this one, when you multiply this all out, okay, if your answers do not match, please ask for some assistance. Please ask for some help. Thank you so much, and go ahead and try the next set of problems. Thank you.